Okay, this is just going to be a quick review of Unit 6, Uranus and Neptune from Mr. Sellers' astronomy class. Just overview of the notes that we talked about in class, just for review. Both of these planets are grouped together because they're very similar in most regards. They're the same size. They're very far out in the solar system. The last two planets, same color, roughly. So that's why we grouped them together. Observation of Uranus from Earth. We first started observing Uranus. We were able to see several decent-sized moons around it, including Ariel and Umbriel, and you'll see Miranda, of course. Herschel, William Herschel, was the guy who discovered Uranus in 1781. It was believed to be the last planet at that point, but it was not. He was British. He wanted to name it Sidious Georgium because he wanted to name it after King George. It's the same King George that America fought in the Revolutionary War. And basically the astronomical community at that time suggested that he kind of keep with the trend of naming it in the Greco-Roman naming of the planets, just like Saturn and Jupiter and so forth. So they named it Uranus. It's not Uranus, it's Uranus, and Uranus is the father of Saturn. We didn't get an up-close look at it until 1986 when the Voyager 2 passed it. It's the only probe that has passed Uranus so far. The New Horizons, which is going to Pluto, will head out that far, but it's not going to be able to stop by Uranus. Just, the orbits are off. So, showed us a pretty much featureless planet, devoid of spots or storms. Now, you can see some stuff here on the screen that's kind of whitish, right? These are believed to be clouds, but it's not quite oval storms like we see on Jupiter or Saturn. Again, this is from Earth. You can see the planet itself is kind of bluish color, and you can clearly see several decent-sized moons around. So we'll jump over to Neptune and talk about how that was discovered. Neptune is a astronomical or astrophysics kind of dream come true. It was discovered mathematically, or predicted mathematically, before it was discovered. They noticed that Uranus's orbit was kind of weird and that something was kind of making it slow down and speed up slightly, and they basically theorized that it was a planet. And in 1840, John Adams, not the John Adams of American history, but he was British, and Urban Lavoisier, I'm not sure how you say that, started calculating the orbit of a new planet. So John was British, Urban was French. They both kind of predicted it roughly the same time. It's kind of a historical debate of who really found it. Neither one of them observed it because they were theorists, much like Kepler. But they sent their information to Johann Gale, who discovered it observationally in 1846. And he was German. So it's kind of a early European Union, if you will, to discover a planet, which is very interesting. So, observationally discovered in 1846, based off of Adams and Lavoisier's information. So, this is what Neptune looks like close up. It took Voyager 3 more years from Uranus to Neptune to get there. So, I mean, you just understand that distance. Neptune's got this very nice feature here. It had, I have to say, just not there anymore. Another great dark spot. Very beautiful planet. Physical properties of both of them. They're almost the exact same size. It's kind of weird. It's similar to Earth and Venus. Uranus and Neptune are kind of twins. Uranus about 4 Earth radii, and Neptune's about 3.9. So, I mean, it's really, really slightly different. Neptune's a little less dense I'm sorry, Uranus is a little less dense. Neptune's a little more dense. They're both still gas giants, of course. Uranus has a interesting rotation. First of all, the rotational rate is 17.2 hours. So, again, faster than a terrestrial planet, but it's not as fast as Jupiter or Saturn. The axis of rotation is about 98 degrees relative to the ecliptic. Now, what that means is it's basically tilted on its side. So we believe that something hit it, something large hit it. Some people even speculated that it could have been Pluto that hit it, but no one knows, of course. It's just simply a theory. But something has turned it edgewise to the ecliptic. Here you can see it. You can actually see the ring around it too. And this is observational evidence that it's on its side, besides the ring. Here you can see what they're trying to show you here is that these spots A and B are moving. So A's, you can't even really see it. B's kind of there, really, but or B's here. I'm sorry. Yeah, A you can't see it. No, actually no. I'm sorry. That's A over there. And then a later time, right, 1320 to 1634. This moved around this way. B's up here right now. I don't even see A, but apparently it's up here somewhere. Anyway, it's just showing that it's tilted and rotating that way. Due to this, it causes crazy long seasons on Uranus, and only one side of the planet, really one half of the planet, gets sun at any one time. When it's here, obviously, it's only the northern hemisphere. Here, it's only the southern hemisphere. You know, you're talking for years. I mean, this is the thing. Here is getting basically equal sunlight on the entire planet, but it, you know, because it rotates 17 hours. So, in the autumn and spring equinox time periods, it's definitely getting more sunlight distributed over the entire planet. Uranus and Neptune almost identical compositionally. They're almost all hydrogen, a little more helium than we see in Saturn and Jupiter. They have a lot more methane than Saturn and Jupiter. Uranus has about 2%, Neptune has about 3%. The more methane the planet has, the bluer it appears. And the reason of that is that methane reflects the blue wavelength of light. It absorbs the red, so the only thing we see is a bluish color. Uranus has little or no internal heat. Because of this, we don't believe there's any convection going on, and we see no substantial weather due to this. We might see a spot here or there, or a cloud here or there, but it's nothing like the storms that we see on Saturn or Jupiter. In '89, when the Voyager 2 went past Neptune, we noticed that it had what scientists creatively named the Great Dark Spot. And the Great Dark Spot kind of looks like the Great Red Spot. It's large, oval-shaped, cyclonic storm kind of thing. It's very large, about the size of Earth. But it's no longer there. We started looking at it observationally with the Hubble in the mid-'90s, and it was gone. Has really high winds on Neptune, close to 1,500 kilometers an hour. So, has something going on there as far as weather-wise. A little more than Uranus. Both planets have a rocky core. Again, it's kind of similar to Jupiter in this kind of terrestrial kind of core region. That's probably not like a planet, but we're not real sure what it is. It does not have enough atmospheric pressure or gravitational force to force hydrogen into the weirdo metallic hydrogen state that Jupiter and Saturn have. But on the other side, it does have a magnetosphere. So we believe that there's a layer of hydrogen water clouds. Underneath the hydrogen, there's a layer of H2O water clouds. And probably a fairly dense region of clouds, and these water clouds are circulating quickly due to the fast rotational rate. and it's causing lots of static electricity, and static electricity causes a magnetic field to arise. So we believe that it's basically like super lightning storms and so forth happening in the slush region, and this creates static electricity and therefore the magnetic field. See the diagram of it here. I mean, it's here you see Jupiter and Saturn. They have the metallic hydrogen kind of regions that are generating ridiculously strong magnetospheres. But if you look here at Uranus and Neptune, the slush region is this little purple ring here, and this is where we'll be. It's a region of really dense water clouds causing static electricity and lightning, and therefore magnetic forces. So they have magnetospheres about 100 times as powerful as Earth, so it's very, very powerful. And we'd expect it to be with a planet that has, 4 times the size of Earth. Uranus's magnetosphere is displaced from the center, whereas like Earth, you have the Van Allen belts kind of come in at the North and South Pole, but it's basically the center of the North and South Pole. Uranus doesn't have that. It's a little bit off kilter, and we believe that it's probably due to the impact that possibly could have tilted the thing onto the side. So it's definitely a mystery, but lots of good theories about that. If something hit it, the core region of it hard enough, then it could displace it. So the magnetic fields here you can see Earth's magnetic field rotates within an 11-degree area, right? This magnetic field's always in the move. Jupiter the same. Saturn's going to rotate it a little bit, but Saturn's is pretty straightforward and stays the same for the most part. Uranus wobbles 60%, and it's definitely off kilter. Now Neptune's a little bit off kilter too. So other people have theorized that get out there far in the solar system and the core region of a gas planet could just be unstable and kind of wobble around. So definitely not clear. And again, some of these these 2 planets, we know so little about them, just based off of Hubble observations and the one Voyager 2 probe that's went past it. And they literally did, Voyager 2 literally did a flyby, didn't even orbit it or anything. So there's some moons of Uranus and Neptune. This is Earth's moon in comparison. So they're kind of large. They're not anything like Titan or Ganymede or anything like that, or even our moon. But there's some of them that are decently large. So Uranus has about 27 moons currently. 5 of them are medium-sized. These are Miranda, Ariel, Umbriel, Titania, and Oberon. So it's confusing because you have Titan and Titania. Titania is a moon of Uranus. Then we're going to see Triton, which is a moon of Neptune. So you have Titan, Triton, Titania. It's kind of confusing. But each one of them goes with a planet. They're composed of ice and rock mostly. They're basically fairly large captured Kuiper Belt objects or comets probably. And they have this condition, what we call radiation darkening, that causes a reaction with organic compounds and solar wind particles that turn some of the surface like a darker color. Basically is caused by radiation, UV radiation, and also solar wind. This is a picture. This is just kind of some facts about the moons. Again, you don't need to know these distances and all this kind of stuff, but here you see a picture of Uranus and see some of the moons around it. These are some of the larger ones, obviously, and I like this picture because it shows how the axis of the planet is tilted, and it shows how they're orbiting around still the equatorial region. Miranda is one of the more interesting of the moons of Uranus, and it's all these little pictures I have here from the movie Serenity, which they go to a planet called Miranda, so that's the reason I have that there. It's not really, they're not really needed, it's just kind of interesting Hollywood references to it. Triton is the big moon of Neptune. It's the only moon in the solar system to exhibit retrograde motion. I know that's not the way you spell exhibit. So it's weird. Something's bizarre about that, right? It also has a very weak atmosphere that's composed mostly of nitrogen. And it has numerous frozen lakes of H2O. So Triton is easy way to remember that Triton goes with Neptune is Neptune carries a trident. So if you remember that, Neptune, of course, is Ariel's dad in Little Mermaid. Those are some shots of Triton. Very pretty. And these are believed to be frozen lakes of H2O water. Hard to say if life is possible there. I'd say unlikely, but you know, it's hard to say. Rings around Uranus. They were observed using stellar occultation. It's a hard word to say. Occultation. What it really means is that it's obstructing starlight to prove something is there. So this observer here looking at the telescope, if they're looking at this star over here and all of a sudden they notice a decrease in light from the star, this leads you to believe there's something in the way of it, and the only thing in the way of it could be something right here around Uranus. So that's how they were discovered. So here you can see in the graph this intensity of starlight. So this, whatever unit this would be in, when Uranus moves, right, the intensity of the light decreases. It's fluctuating because it's hitting ring materials, right? Then it misses, then it's in between two different rings and goes back up to high, and then it comes back down here for, you know, this ring is probably denser because it's definitely getting less light through. So anyway, that's how they discovered it. When the Voyager 2 went by, it took lots of photographs of Uranus's rings, and they named them. And the names are all kinds of wackadoo. 86U2R and 86U1R. These are references to, these are catalog numbers that they named because they found them in 86 when the Voyager 2 probe went by. They started going a little bit Greek. This is the first one discovered. So you have alpha, beta, eta, gamma, delta. I don't know the Greek alphabet. But there's epsilon. So when the Voyager got out there, they started finding some other ones, and then they named this one 4, 5, 6. So the naming of these rings also a little crazy, and they're also, you know, they started off one way, and then as things were added to this, the order didn't make sense. So see, the stellar occultation ones that were discovered were the alpha and the beta and the eta and the gamma, and then these were kind of discovered later, and they were inserted wherever that fits. So there's no rhyme or reason to it, basically. Uranus has 2 shepherding moons, and these are just identified as 1986 UB and 1986. I'm sorry, that's U8, and this is 1986 U7. And these are the names of the moons right now, and they're shepherding in one of the rings of Uranus, much like Saturn. This bar is here on purpose to block the reflected light from the planet, so it will reveal more of the ring structures. So this is from Neptune. Neptune has rings, and you'll notice some of these familiar names. Gales, the guy, Johann Gales, the German who actually discovered it observationally. Lavoisier is the French mathematician who predicted it, and Adams is the British mathematician who predicted it. I'm not sure who Lassell or Arago are. And that's about it. I'm not really going to chat about Pluto too much. It's definitely not going to be on any test or anything, but these are, I will show you a couple of pictures of it just for fun. Pluto is, this is a artist rendering of Pluto based on the Hubble information. So we're not quite sure. We'll find out in a couple of years. These are literally the best shots of from Hubble of what Pluto looks like. So the artist rendition is trying to like figure out if there's craters and so forth and areas of different, you know, colors. So that's kind of where they're getting this idea from. but it's interesting. Only planet discovered by an American, which is why America really didn't want to lose Pluto as a major planet. Orbit of Pluto is weird. It's really, really elliptical, which is another reason that makes you think that it's probably more of a comet. Because see, if you see here, right, this is definitely not the center. It's not very circular. And one of the interesting things about Pluto is that there is a time period of about 20 years where Pluto actually moves within Neptune's orbit, and Neptune will become the 9th planet. So it's kind of an interesting fact. But again, we've taken it out of the planet equation. That's the shot of Pluto when they discovered it. Sorry. This was the idea that Pluto moved. So here you can see these little 3 background stars. There's the 3 background stars again. So it was here, now it's here, right? So it's moving this way. Notice the background stars didn't move. So that's the way that Clyde Tombaugh discovered Pluto. Hubble revealed that Pluto had a moon. And the moon is this little guy right here, which is Charon, or Chiron. And they actually are what's known as a dual planet system, where Pluto's slightly bigger, we believe, but since they're both very similar mass, they kind of orbit around each other. So it's a very interesting idea. And that's about it. Hope you enjoyed that.